Welcome to the Nerves Meetup, everybody. This is the one for February the 26th. Nerves Meetup is sponsored by Redwire Labs, where we help companies do custom firmware development, specializing in nerves. We have a handful of nerve systems as well for those of you who are interested in playing around with these and using them in a commercial project. We've got a handful of announcements today. Number one, NervesConf US. That is coming up quick. It's still co-located with Gig City Elixir this year. So coming up on May 8th is when the Nerves Conference part of it starts. And then the 2 days after that are Gig City Elixir. So you can purchase tickets as a bundle for both of those and get a little bit of a discount. The website for that is gigcityelixir.com. Anybody interested in speaking for this, I think we still have a couple NervesConf speaker slots available. Just get in touch with me and I'll give you the link for the CFP so you can get on the list for that. Then later in the year, we've got NervesConf EU hosted by Lars. So he's kind of like the Geek City theme. This is Goatmeyer Elixir is going to be the general Elixir side of things, and there's a NervesConf EU part that goes along with this. So the 10th through 12th over in Sweden. And Lars says if you sign up early, you get a free goat with your Goatmeyer Elixir ticket. So be sure to do that. Next month, we have Josh from Nerves Cloud talking about Nerves Cloud here. So should be a pretty cool presentation. Nerves Cloud is the way to do OTA updates on Nerves. So already integrates with a Nerve system and gives you the all the tooling that you need to do that. So pretty cool platform, and there are some pretty cool updates coming along with that he'll be able to talk about. That being said, tonight we've got Gus Workman.
So I'm excited to talk about Soleil, the project that I released last month, and kind of what we're up to and some approaches to open source hardware in Nerves. So first about me, my name is Gus. I'm from the US. I currently live in Luxembourg. I've been doing independent consulting for hardware development for Nerves, and I've been working with Nerves for like the last 3 or so years. So let's just jump into it. We're gonna start with like a high level overview of why you would want something, the features that Soleil can provide. And Soleil is really targeting these low power, off-grid or portable types of deployments. And so let's take a look at an example project. Suppose that you want to make a weather station and have it sync weather data with some remote server. To do this with Nerves, we're going to start with some type of computer. So in this case, we have the Raspberry Pi. And if you're deploying it, you are going to need power. So you add in a battery. And if you have a battery, you don't want to go out there and recharge it all the time. You hope it's going to recharge itself. So you add some solar panels. From there, of course, you need your sensors. So you have your temperature sensor, maybe you add in some anemometer for wind sensing. And then you have, most of your project is complete, but then you need to actually send the data somewhere. So you add some communication layer, like a LoRa hat. And this is great. You have all these discrete components, which help you manage your project. But if you hook it up like with all these different breadboards, what you end up with is the rat's nest of wires, or I had a friend call it the noodle salad of wires on your desk. And not only is this not very, is it going to be hardware that's full of bugs and hard to debug, but it's also not very easy to deploy in the field. So Soleil then is tackling this type of problem, this general problem that can be split into 3 parts. First of all is the features. We want a complete battery management solution with a low power mode. But we also want it to have support, the support type of the problem. We want it to have first-class support for Nerves. Nerves is a great framework. We love using it and all of the tools that are in the ecosystem. So we want to have first-class support. And finally, usability. I think this one is really key in where Soleil is doing some interesting, has an interesting approach. But we want the the solution to be simple and flexible, yet it should grow with your project. It should be easy to prototype, but also later on, it should be easy to turn your project into even further like a custom circuit board. And so that brings us to what I've developed. This is the Soleil board. It has for the features category. So it has a Raspberry Pi Zero form factor. So it fits right on top of a Raspberry Pi Zero. And the base feature is all of the power management. So going back to the weather station, you can power your weather station from a lithium battery. You can recharge from USB-C or from some type of solar or DC input voltage. It has battery state of charge monitoring so that you can get the percent battery life remaining like you have on your phone. It has a low power mode. So we'll talk more about the low power mode later, but that extends the battery life. But it's also not very useful if your board is only in low power mode. So we have different ways to wake it up. So those are features. We'll dive into those a little bit more. On the support side, I love nerfs. So I really wanted this to have first-class support. We are talking about, there's a custom nerve system to support the board, which has a pre-compiled artifact available. I have developed and released the Elixir libraries. Those are available on GitHub and Hex. We have the great Hexdocs tool. So I've been working hard to get a lot of things documented, including hardware in Hexdocs. And one that I'm really excited about is the Nerves Key chip on board. So if you're not familiar, Nerves Key is a certificate management, a hardware management chip, and it allows you to securely connect to Nerves Hub and Nerves Cloud, which it sounds like we'll be hearing about next month. But as a remote firmware management solution, it's a really cool tool in the ecosystem for Nerves. And so by having this chip on board, we have, again, we're prioritizing first-class support for Nerves. So that all is really important. But again, the usability is where I think we do some interesting stuff. So not only is this all open source hardware, if you're familiar with the Open Source Hardware Association, they do a certification process. Since open sourcing hardware is a little bit more complicated than just releasing a library on GitHub. So I'm working in the process to get it certified. But the other thing is the connector on the right side of the Soleil board is called the Quick connector. It's a standardized I2C bus released by SparkFun and adapted by Adafruit and a bunch of other of these like hobbyist or breakout board manufacturers. And that's great because it means that there's hundreds of third-party sensors, actuators, screens, and so on that you can then now just plug and play and build your projects with. So in the case of the weather station, you can start by using Soleil and plugging in via the Quick connector all of the sensors that you might want to use on your weather station. And then from there, you can, like it's plug and play. There's no chance that you would have the rat's nest or noodle salad, no chance to mix up the wiring, but it allows you to get started quickly. But this is where I was mentioning that Soleil should give you room to grow. Once you're done prototyping with this type of solution, the Quick connector, I wanted to make it really easy to upgrade your project to have a custom circuit board and make it really easy. I know, so I have a computer engineering background. I have a lot of experience in designing circuit boards. However, I know it's not a very approachable concept. And so I'm trying to make this as easy as possible. We have the whole board was designed in KiCad, which is the open source open source PCB design software. So that's all free. You don't need any special licenses to download the source files and modify them. And then I've left all this open area on the board so that you can add custom circuitry. You can add those weather sensing chips. You can add the, I don't know, a special interface to some other type of circuit board that you have in your system. So there's this room for you to grow with the project, and it should be easy. I've spent a lot of time, as you can see, cramming all of the power related circuitry on the left side so that there's this big open area for your custom circuits. And so I'm really trying to take an approach here where the community can take this design and then kind of run with it. Okay, we're going to go back to the features really quick. So I was mentioning the power system, and we're going to take a look at some of the data and the how it all works. So specifically the low power mode. So low power mode is really important because that it is what extends the life of your battery. And for Soleil, we are consuming less than 20 microamps in low power mode. For comparison, the Raspberry Pi 02W idles at around 230 milliamps. So it's around 10,000 times less power than when the Raspberry Pi Zero is in idle. With the battery pictured in that you can see here, it could be in sleep mode for around 2 years with a full battery. For the wake up sources, we have on board, there's a real-time clock, which has an alarm, which you can configure for any second up to 1 year in the future. So if you want to set a timer to periodically wake up the board every 15 minutes and record your weather station measurement, you can do so using the real-time clock and wake up, read the sensor, and then say, wake me back up in 15 minutes and go to sleep. There's also manual methods to wake up. There's a push button on board on the left side, and then a Hall switch. This is one I'm really excited about as well. So a Hall sensor is just a magnetic sensor. So it senses if there's a magnet within a certain proximity to the sensor. The Hall switch just outputs a 1 or a 0, depending on whether or not there's a presence of that magnet. And you can see here, I have a little video. If you look on the left side where my thumb is in the video, there's a little slider, and the slider has a magnet embedded in it. You can see the magnet on the right side. When the slider is moved up into position like that, it toggles on the board, and you can see the red power LED there, plus the green Raspberry Pi LEDs on the back right side of the case. So the reason we have a Hall switch instead of having some type of button or something is that it means we can manually trigger the circuit without having any mechanical or physical parts poking through the case. So you don't need to wire a switch to the outside. You don't need to wire a push button through the case. So it can be fully weather sealed without any sort of the breach in the case. So I think that one's pretty cool for manually controlling it. Talking more about low power mode, I am going to show you some data on the next slide that I recorded this past week. But I wanted to show the setup for what the test kind of looked like. So we have here the same board mounted inside the case. There is a small solar panel. It's about 65 millimeters square or 2.5 inches. It's 0.6 watts, 6 volts. I tilted it approximately 45 degrees upwards on a south-facing windowsill. But this is, again, I live in Luxembourg and it's very cloudy here most of the time. So not ideal conditions by any means. But this is what we have for the past week. So the red on the and the scale on the left is the voltage of the battery that was measured when it woke up. And the blue on the right is the state of charge, or the percentage, the battery percentage. And you have these yellow and blue bands here that's representing approximately the daylight hours. So yellow is during the day, blue is at night. And the board just woke up. I had it set on a 15-minute interval to wake up, record the battery percent charge and voltage, and then go back to sleep for 15 minutes. And so what we can see here is it started at around 4.1 is approximately fully charged for this battery. And we can see that during the nights, it starts decreasing slowly. But during the day, on the first couple days, we had a pretty nice amount of sun and it was able to recharge to full. But towards the end, on the weekend here, we had a bunch of rain, and the battery did not charge during those days. And you can kind of see that reflected in the state of charge, the blue on the top right, as it starts to go closer to 90% charged. However, we had a bunch of sun this morning and it charged it back up to 100. So even though it wasn't necessarily ideal conditions, it was enough for this 15-minute interval. Now, of course, if you need to power your Raspberry Pi for longer periods of time, you might need a larger solar panel. If you have like types of work that are very one-off, such as like, I don't know, you need to take a picture every Monday at 2 p.m., then perhaps you can get away with a smaller solar panel. But yeah, so it's kind of interesting. And there's a bunch of calculations that go into the solar panel specs. We're going to move on now towards the support for the board on the Elixir side. So the driver library is actually quite simple. There is just a few functions. So you can get the battery info, and this is the function I was showing earlier that I was using to record the data shown earlier. You can get the instantaneous average current. You can get the state of charge of the battery. You can get the temperature of the battery charging chip, and you can get the voltage of the battery. From there, you also have a few functions which, like the wake up reason function, is useful because we can tell whether or not the wake up or the power on event of the Raspberry Pi was because of the real-time clock alarm. So in this case, for example, I found this one to be really useful because we can selectively enable the Wi-Fi only when the wake-up reason was manual. If the wake-up reason was scheduled, or the real-time clock, then we don't enable it and we go right back to sleep. So this is really useful for debugging because I can say if it was manual, then let's turn on the Wi-Fi and go back to sleep after 15 minutes of inactivity. Whereas when it's just on the timer, we don't want to be wasting power. So turn off immediately, record the data and turn off. For the turn off functions, we have sleep, the two sleep functions here, sleep for, and you can specify a duration of time, or you can specify sleep until and pass in a UTC naive date time. Yeah. And then I also wanted to point out the nerves key. So if you add the excellent library by the Nerves Hub team, then it's really easy to integrate and you can actually see if it's provisioned. That's another nice one. And eventually I'd like to have some monitoring, maybe the battery percentage as an available metric for Nerves Hub, just out of the box, because I think that would be nice for, I see Josh here giving a thumbs up. Perfect. And then, okay, so we're getting into the end here, but I wanted to also mention that, like, of course, there's other boards that do this type of that you can buy and will power your Raspberry Pi. However, they all have one, in my opinion, they all have one flaw, and that is that they are all based on microcontrollers. Each of these boards that you see here has a microcontroller on it, which controls the Raspberry Pi. And when we're looking at this from the open source perspective, if someone was going to take the design and order it themselves, have it manufactured, and customize it for their need, it's one extra step to then also compile in probably C a firmware for a microcontroller, and then verify that it's running correctly on the microcontroller, and just like all these steps. I like Elixir, I like Nerves, I like sticking with it and keeping it as simple as possible. So Soleil is without a microcontroller. All of the circuit, all the chips on there are discrete components, and so they don't have any code that you need to load. They don't have anything like that, and so you only need to add one line in the config.txt. This is for if you're creating a custom nerve system, because the default one that I've published already has this built in. You just need to add the overlay for GPIO power off. And what that does is basically the last thing before the processor shuts off is it toggles a GPIO pin. And that GPIO pin tells the power controller to say, hey, it's time to go into sleep mode. And so you can use the regular Nerves runtime power off command, and it will go into sleep mode automatically. It'll just be indefinite because you haven't specified a wake source. So we get to the point where I'm going to show a live demo of also how easy it is to customize the hardware and the actual circuit design. But I wanted to stop here and see if there was any questions first before jumping into that.
How many can I buy right now?
That is a good question. So the next slide is on, I want to run a group buy for the boards. So right now there are only 5 in existence, and they're all sitting on my desk.
That was a little bit tongue-in-cheek, but I'm really impressed with this.
Thank you.
One thing, just because I know a little bit more about this, Gus, that you haven't touched on is the added support for the real-time clock that makes adding that portion in so much easier than other solutions that are out there. So you might want to touch on that a little bit.
Sure, I can mention that. Although, to be honest, it isn't too much of me. So if you've used the Nerves Time library, if anyone here has used Nerves Time, it is incredibly easy to define a gen server, which then acts as the interface layer for your real-time clock. And so when I wrote the driver for the real-time clock on Soleil, I'd like to get it published, maybe a pull request into Nerves Time to add it as one of the default options. But yeah, so Nerves Time manages pretty much everything for you. You just need to define the interface functions to say, this is how you get the time, this is how you set the time. And then I have a few helper functions for getting and setting alarms. Again, Nerves Time takes care of all of the hard stuff like NTP and syncing the clocks and all of that sort of stuff. So having the real-time clock on there is actually quite nice, because when you don't have network connectivity and you wake up on your off-grid deployment, you still know what time it is on your device.
You mentioned you aren't using a microcontroller, so are you talking directly to a PMIC, or what piece of hardware is doing that sleep management?
Right. That's a good question. There is a they market it as a nano power load switch. And what it does is essentially it has two inputs. The two inputs are a power on and a power off. One of them is active high, one is active low. I can't remember which one's which at the moment. But when the Raspberry Pi says I want to shut down, I think it does active high on the turn off input. And so then that disables the output of this load switch. And then that turns off, that just goes to the enable pin of the 5-volt boost converter. So, and then on the other input, it's the power on. And I think that one's the active low, because all of the wake up sources are open drain. And so they pull the pin low just briefly. And it's basically, the chip is just looking for edges. So anytime it sees a low edge, a falling edge, then it will say, okay, time to turn on. So you can press after the output has been enabled, you can press the push button or set the alarm however many times you want, but it's just going to turn on, just going to stay on. Yeah, it's a nice chip. It's made by Torex Semiconductor.
The one I had for, which I think might be useful here, is how do you kind of go about finding solar panel, right? Like, is that, that's kind of an unknown, I think, to a lot of us. And is there some just readily available? What are options on if you wanted to tackle this project?
Are you more so asking what size solar panel do you need, or are you asking where do I buy solar panels?
Well, kind of like
everything.
How do I kind of go about, the process? And maybe if it's not of interest to everyone, it's just right. Like, I mean, you guys know I'm on a boat, right? So my solar panels are like 3 feet by 4 feet, right? So I can't hook that up. So I think that's.
So the way I've designed it right now is I had spec'd it out to choose a solar panel which would provide enough power with a significant amount of buffer to I basically took the amount of time that I expect the Raspberry Pi to be on, which is about 10 to 15 seconds every 15 minutes in this scenario. And then look at how much current is that actually going to take and consume. So for 15 seconds, it's like 3,000 milliamp seconds. I think the units get weird here. And then I take that, and if you then divide that by I want to say it was 1,500. I don't know. If you divide that with however many seconds are remaining in that 15-minute interval, then you get the average power consumption per se. And so you then would kind of take that and double or triple it, because solar panels are not super efficient. And so then you kind of get the ballpark for what size and what wattage of solar panel you need. The one thing I will say is that I have specifically designed it to be pretty compatible with as many solar panels as possible. The DC and solar input accepts up to 16 volts. And the tiny panel I have here is only using 6 or like at the maximum output, it would be 6 volts. So if you needed bigger panels or panels in series, it would be more efficient because like when it's cloudy, the 6 volt panel isn't reaching I think it's like 3.5 volt minimum where it would start charging. But if you had 2 of these panels, solar panels in parallel, a 12 volt on a cloudy day, you'd probably still clear the 3.5 volt minimum.
Another question for you is the startup time. So you mentioned being able to like bring the Pi back up in 15 seconds. And if I remember right, the off-the-shelf nerve system on a Pi boots in, I think it was like 30 or 45 seconds. So are you actually able to go into like a low power sleep or hibernation mode where you're not actually losing all the memory on the chip, like everything that's in RAM, and you're hibernating? Or is it actually powering off and you're having to boot back up again?
No, so that I think would be a feature that Raspberry Pi would have to enable for the keeping all of your memory. So we're just cutting the power completely. It loses it has to start with the cold boot every time. However, I haven't seen that it's the 30, 45 seconds. Lars had sent me a guide that someone was optimizing their Raspberry Pi Zero 2W with build root to get it to boot within like 3 or 4 seconds. I haven't done any of that yet. I would be interested in doing it. But I think my current limitation is that I don't have the proper tools to test this the power consumption in this way, especially with the low power mode, because most tools won't be able to measure the swing of currents that we would need to actually measure. So it goes during boot up. It's I think it sees peak currents of like 700 milliamps, 700 or 800 milliamps before going down to idle at 200. And then you need to have 700 milliamps and then measure 20 microamps. Yeah. So most tools are not. Yeah.
Have you heard of the Joule scope?
I have. Frank was mentioning it to me. And so I think at some point I would, he mentioned he'd like to get his hands on Soleil, and maybe there's opportunity for some build root optimization, pull out unneeded modules there and whatever, slowing down startup.
Yeah, if you need some energy measurements and are willing to get rid of one of your 5 samples there, I'll just say I kind of might know somebody with a Joule scope. Cough, cough.
Okay, that would be cool. I would love to see the community kind of getting involved with making the software better. Well, I will, I guess, go into the demo. So the schematic, I've spent a lot of time trying to make this very clear and well documented and well put together, so that anyone can come in here and kind of modify it. For this example, I'm going to continue with the weather station, and I have picked out the chip. Granted, I am quite familiar with this software, so this will be a quick demo relative to if you're inexperienced, you might have a bit of learning curve. But we'll see what we got here. So here I have picked out the BME 280. It's a temperature, humidity, and pressure sensor made by Bosch. And it has an I2C interface. So I'm here on the quick connector page, and I'm just going to hook up the connector. I've already taken a look at the data sheet, so I'm kind of cheating here. But these types of I2C connectors are usually quite easy to hook up. They connect the clock and the data lines, and then connect power ground, and then you usually have to check the data sheet to figure out what to do with these other pins. So this one, for example, it has an SPI interface as well. But for the purpose of this demo, the other pins get tied to, and I'll show you where I found this in a second. It just gets tied to the ground and power bus. Let's see, I should have pulled this up. There it is. So here is the connection diagram for I2C. I have BDD, BDDIO, SDO is the I2C address bit, SDI, SDK are SDA and SCL, and CSB gets connected to power. So it looks like I hooked that one up wrong. But you can see with these types of I2C connectors, it's quite easy. The number of components is limited, and yeah, it doesn't take a electrical engineering degree to add this type of chip on here. From here, now that we've added this, I will go ahead and import it into the, here we go. And so here's the layout. You can see all the mess of traces that I have here on the left side, where I've basically crammed all the components compactly over here so that this area is open for your use. So I'm going to go ahead and import. And here's my new component. I just put it in a random spot here. And KiCad will tell you how to hook things up. So now that I've put it on here, I basically click on the pads and it'll tell you how to do it. So the ground one's already connected. And then from here, all we have to do is hook up I2, the SCL and SDA. So that was a via. It goes down to the layer underneath it. As you can see, I2C, SCL, SCA, SDA, and regenerate the net. And then let's take a look here. There we have it. That's all it takes to add this chip. So that's the really quick demo. Let's see. Close. Back to the presentation. So we had this question earlier. How do we get one of these? How do you get your hands on them? I have a wait list that I threw out when I made the post on the Elixir forum. If you want to sign up, if you're interested in getting your hands on some of these boards, if you're not already on there, you can either scan the QR code, go to the URL. I'm trying to do this in Q2 of this year. So the next couple of weeks, I'll be communicating via email to get the approximate count of boards that people are interested in ordering. The order deadline is going to be the end of the month, March. And that is so that we can try and get these in by June at the latest. I think it should be sooner, but I'm adding in some buffer time because hardware is hard to produce, hard to design, hard to produce. Approximate cost for the boards here are around 30 to 35. If we get more signups, that might come down to 25 to 30 because the economy of scale is quite real. For the battery case, the one I was showing the pictures earlier, I had a few people ask me about this one. If we end up selling it, if I end up selling it, the files are all open source. But if you wanted an assembled version, I would consider doing that if there is enough interest. I think that one would be around 20. The solar panels themselves in medium quantities are like $11. So it's that's where most of the cost is. The rest of it's just 3D printed and some screws and hardware. I can't, unfortunately, sell batteries to go with them. However, I did design it so that it is compatible out of the box with all of the batteries that Adafruit sells. So the connector that comes on those batteries and the polarity is the same. So if you get a battery from Adafruit, you're set. If you don't, check the polarity beforehand, and I'm going to send some of the JST pigtails with the board so you can solder on your own. Yeah, I had some resources here if you wanted to take a look at anything. The repos are all on GitHub. There's a demo code, the one that I was recording the data with. And I posted, if you're curious about the hardware, I posted a more detailed hardware overview on my blog. So yeah, give that, feel free to check that out. Yeah, so this is like the Soleil side of things. This is what I've been working on the last couple months on and off. And it was a lot of work to get it ready to where we are now. So I'm really proud of this launch, and hopefully I want to get it in your guys' hands soon. But I also kind of wanted to talk a little bit about what I'm working on next, and also kind of open the discussion for I think what I'm kind of calling is Nerve's first hardware, and the community approaches that we can take for developing Nerve's first hardware. So if you've taken a look at the ElixirConf EU talks, you might have noticed my name on there, and I'll be talking about what I'm calling Project Trellis. And the goal for this is taking the same approach for Soleil, where I've developed the whole power system and left space for you to design your own custom circuitry on the board, but then apply this to an actual single board computer or SBC, like Raspberry Pi or something like that. Now, note, it's not going to be very fast or powerful or feature rich. It's going to be pretty bare bones, but I think having a Nerves first board, Nerves first hardware for the Nerves ecosystem, I think is going to be beneficial, especially if it's a design where it's all open source and you can add your, I don't know, like a RS-485 transceiver on your board and not have any like hats or backpacks or whatever the single board computer companies call their add-on boards these days. So anyways, let's talk a little bit about what this looks like. It's going to have a T113 S3 CPU from Allwinner. It's dual core, 1.2 gigahertz, and has 128 megabytes of RAM built in on the chip. You can see the chip here on the right. It's not BGA, where they have the balls underneath the chip, but it has this relatively nice broken out package. So it's more approachable for hobbyists and, I don't know, repairs if you need to do it. The other nice benefit for this chip is it comes in single unit quantities at under $6. So the whole BOM cost for this board, I'm trying to get under 20. The board will have eMMC storage, Wi-Fi, Bluetooth, Ethernet, 2 USB-Cs, one for power, one for data, and then just a smattering of connectors. So like the quick connector I showed before, also some stuff for UART, SPI, and CAN. So more of a dev board for sure. However, again, I want to take the approach of leaving space for your own custom circuitry. It'll also have the Nerves key on there again. I'll be working on a custom Nerve system. And from there, it's kind of where the community takes it. I've talked with Lars. He mentioned maybe trying to do secure boot on it because that's one of his projects as of late. So the chip does support the trust zone, ARM trust zone. So it would be kind of cool to add that there. Again, that's really where we take it as a community. And then, of course, on the usability side, it's open source. And again, taking that approach of let me take care of the hard stuff, the high-speed interfaces, the power sequencing, all these like the nuance where you want more experience in developing this type of board, but then leave space for you to bring your own application-specific circuitry. So I don't have renders of this yet. I'm still working on this, but I will be launching it at ElixirConf. And I post my project updates on Blue Sky mostly. So if you are interested in following me, that's where you can learn more usually. I'm also on the Elixir Slack, Elixir forum, LinkedIn. I use this picture pretty much everywhere. So if you want to get in touch, if you have a use case for Soleil, or you have ideas for what you want to do with the trellis board that I'm working on now, definitely get in touch. But yeah, that's pretty much everything I had for this time. Can open it up for questions again.
It's both a question and a request from me, I guess. The question is, if you are to do like pre-built kits, are you going to make sure that we are at least giving you some like adequate compensation for it?
Yes, so thank you, first of all. It definitely means a lot to me to hear people talking, like, get it out there. And I'm excited. That's why I'm up at this hour. But in terms of the kits, I mean, it's going to be, I really want to emphasize that if I was looking to make a bunch of money off of this, I would probably write a Python library and start marketing it for the Raspberry Pi on the Raspberry Pi forums. I mostly want to cover my costs and maybe a little bit extra, basically the buffer that I build in for in case the costs are much higher than I expected. It's not really about making a bunch of money on it for me, but really getting it in the hands of the community. So
I mean, that's super awesome of you. And I guess now my request would be that I want to make sure that, you know, I really want to buy multiple of these kits. It's funny timing because I went into a deep dive of trying to find out what's a good solar kit, because as you can see, I'm in the country, and as anyone who moves out here, you want to like measure water tanks. It's almost like the, you know, IoT 101. And so your kit is perfectly timed. I want to buy multiple, but I also want to make sure, like, you know, there is a nice way of saying thanks. So at least if there is on the order form or wherever it's bought, if there is a way to say, cool, I want to pay a little bit extra to say thanks to Gus, I will be pressing that several times.
Okay. Thank you very much, Josh.
I have actually worked with Gus on 2 hardware projects now, one previous and one current. And it's always been awesome to get the boards, and they work every time, which has been wonderful. And the adding the custom work and his ability to listen to my babble of like, well, let's just maybe add this and maybe add that, and then have him pull it out and get it knocked out is really awesome. So having someone that is conscious of our ecosystem and also with his hardware background is really an asset to the whole community for anyone that wants to get past breadboards and spaghetti noodles.
Thanks, Chris.
Hey, Gus. Quick question. I know you mentioned that you didn't want to use microcontrollers, but at any point in time during ideation of this project, did you consider microcontrollers? And did you happen to look into communications between that and the MPU?
Great question. So I did indeed look at microcontrollers. I had actually done a design with one in there, and had found that I was having issues because it was partially because it was a new microcontroller that I hadn't used before, but also partially because there's several different voltage rails on the board that I was having inconsistent communication issues with it. So that added with the fact that microcontroller, some of the cheaper STM32 maybe is, I don't know, 40 cents. I found the chip that is on here, which I really like, and costs, I think, like 15 cents. It kind of was a no-brainer for switching over to this one. The only downside with this chip that I've seen is that it is marginally less available when assembling with my manufacturing partners in China. So the wait time is a little bit longer because they have to order it from outside of China. So
Gotcha.
that's the main downside. In regards to the second part of your question is communication interfaces with MPU. I actually have something on my desk here that I'm working on, a Raspberry Pi and a STM microcontroller. I guess I'll ask you what limitations or what considerations are you asking this question with? I usually think there's probably some type of background that.
Sure. So like right now, in the nerves community and ecosystem, there isn't really a strong story for MPUs and MCUs and that sort of
Correct.
ecosystem. And so like at Redwire Labs, we've worked with both. We use Zephyr a lot, so that's a C-based ecosystem and framework. But I personally haven't gotten the chance to work on a project where I needed both an MPU and an MCU, and I needed both things to talk to each other. At least not recently. And so like one straightforward strategy is, okay, just open up a UART between both and talk data through UART, right? But then there's something else. There's RP message that the Linux kernel understands, and you can open up a channel between both of those components via RP message. And that's been a strategy that a lot of the hardware vendors have started employing very recently. For example, a lot of the newer IMX8 MPUs that might have an MCU built in, or at least packaged within their EVKs, evaluation kits, there might be the MPU plus some MCU, right? And they've gone through the trouble making it easy for that intercommunication through RP message, and the same thing with TI's latest AM62, which there now happens to be a Pocket Beagle 2 out that is built on top of that. So I'm also hoping to play with that and try out RP message there. But yeah, it was really around like there really isn't a good story right now in nerves for MPU plus MCU communications, and just wanted to get your thoughts on that.
Agreed. There isn't. So I haven't heard much of the RP message before, but now I'm definitely going to write that down and take a look at it. One that sounds similar though is in the Rust ecosystem. I don't know if you've heard of PostStation -RS. That one is a cool one to look at because it is essentially as what you just described, where it's a message passing format, as I understand it, message passing between microcontrollers and host computers. I believe they offer several different communication transports protocols, but yeah, take a look at that one. In terms of the nerves story, one of the things I was actually doing with the microcontroller sitting on my desk here was writing an implementation of the STM32 bootloader to be able to upgrade the running firmware from nerves. If I don't have much to report on that now, aside from I do have communication with the bootloader, but it would be a good asset to the community, I think, to have types of libraries like this where you can update firmware or I don't know, remote procedural calls, RPC, on types of microcontrollers, or similar standardized message format passing, like postation. So I don't know. There's a lot of room in the community, I think.
Yeah, definitely. I don't know if you've looked at Ceph or RTOS, but if that doesn't ring a bell, take a look into that, because there is a bootloader that they have that has bells and whistles to make it possible to update firmware via some utility that they have called MCU Manager. So the bootloader is called MCU Boot, and the utility is called MCU Manager. And I know we've used it in the past in a past project to flash firmware on that microcontroller from a Nerves system. So the Nerve system boots. If it detects that the MCU needs an update, it'll just update the microcontroller via the UART line that connects both the MCU to the MPU. And Cepher does bring in a lot of concepts that you might already be familiar with, like device tree and stuff like that. So it's going to be a familiar ecosystem for you.
Yeah, I'll definitely take a look. I've never played with Zephyr, but I've been meaning to for quite a while. Lately, I think a level lower than that is I've been using the Embassy framework with Rust for writing code with microcontrollers. And they also have a nice not manufacturer bootloader story. And they offer, I think, USB bootloaders, and I don't know. I haven't played with it a bunch yet, but it's something that I'm spending a little more time on recently.
That's very cool. I've been meaning also to play with Rust and Embedded. I just haven't really had the time. But bare metal Rust MCU Embedded sounds amazing. I've seen the libraries, I've seen the code, but just haven't actually dived into it.
I'll tell you, it's definitely been a transition from writing Elixir all the time. It's syntax and the compiler is annoying, but useful, annoying.
Yeah.
All right. Well, thank you very much, Gus. It was great to see Soleil.
Thank you for having me.